Hi, we are Group 36 and have worked on a challenge provided by Hydro in the course Applied Data Science at NTNU. In this video, we will briefly describe the company and problem at hand, how we tackled the challenge, and what recommendations we have for the company. Hydro is a renewable energy and aluminum producer which can be broken down into four main subsidiaries. One of these subsidiaries is Hydro Aluminium Metal, which is the company we're going to focus on for this presentation. Hydro Aluminium Metal is one of the world's biggest producers of aluminum and aluminum products. But what are these products? Well, they produce things such as extrusion ingots, sheet ingots, foundry alloys, wire rods, and high-purity aluminum. Hydro Aluminium's customers purchase these different products in different amounts at different times of the year. The historical customer data is then stored, and we are set to use this data to exploit customers' buying patterns and estimate what the customers are going to buy, both which products and at what amount, and when they're going to buy it. So, why is this important? Well, as of now, Hydro's current processes uses sales data from the previous 4 months to create a sales forecast, and this forecast is then used to create a sourcing plan which decides on which plant to produce each product. 1 to 4 weeks before shipping, the customer places their actual orders. If then the sales forecast is not aligned with the customer order, the sourcing plan would need to change. This could have a negative impact on delivery performance, freight cost, and capacity utilization. Just imagine that we predict a customer to buy 1,000 kilos of product A, but the customer instead order 1,000 kilos of product B. Then this order might need to be fulfilled at a different plant, which could interrupt other orders and break the sourcing plan. So the task we were given was to create a model that has a better estimate of the future mix of products ordered by a customer. The model will be tested against real customer orders, and our goal is to achieve a lower mean squared error on predictions compared to the current model that Hydro uses. The dataset provided consists of historical records of the sales of different aluminum products. One row symbolizes one purchase, and the data is grouped by year, month, customer, area, product type, and product category. Each of these groups makes up a customer's product mix for 1 month. The product fraction defines how much a product makes up of the product mix, and this always sums up to 1 for each group. In our analysis, we use the Python library Profit to forecast the expected future product mixes. This plot showcases one single product for a single customer. The black dots show the product fractions for each month, and the blue line shows the fitted model. The shaded area represents the uncertainty in the forecast. We can now use this model to forecast the next 3 years for that customer. When we do this, we can see that the forecasting model clearly finds a seasonal pattern in the data and also detects an overall increasing trend in the product's expected fraction. If we look at another product from the same customer, we can see that the product had a fraction of 0 from 2018 to 2021. Since the second half of this period has no orders, the forecasting model detects a negative trend. All negative predicted values are set to 0. On the 2 plots we just presented, the model was trained with all available data. However, when validating the forecasting model, we trained it on all data except the last 12 months, which was used for testing. The test achieved a small mean squared error of 0.000484. To have something to compare our model with, we used a seasonal naive method as a baseline. This method predicts the product fraction as the one that occurred 1 year earlier. For example, the prediction for August 2021 would be the value at August 2020. This model achieved a mean squared error of 0.000766 on the same data, which is substantially worse. Based on the results of our analysis, we recommend Hydro to gather more data to further enhance the forecasting model. More specifically, we recommend further analysis utilizing the complete sales data, describing the real volume of each sales and not just the product fractions. Using only the product fractions will not paint the complete picture, as the product fractions might decrease even though the volume of the product increases. Another recommendation we have is to extend the analysis with macroeconomic data from external sources. These data can for example be global prices of aluminum and data about expansions and recessions in the global economy that may affect private financial investments and investments in aluminum products. Thank you for watching.